All right, we are now recording. Thank you, Douglas, for bugging me because I keep. Uh, I am. I'm gonna get. Now I'm getting started. Okay. Ted is having a problem saying that he's still getting kicked out class every few seconds, like last week. Ted, I'm sorry, I can't troubleshoot that right now. We're gonna have to move on. So I'm gonna be okay. Here we go. Thank you. I'm slowing down a bit, so I'll be talking slowly. So, all right. So today we are going to cover. Today we are going to cover just a routine walkthrough with the routines that some of you have done, and then we are going to cover boolean operations, and if we have time, we are going to cover no, Jagdash, we're on CenturyLink. Thank you for the nice comment. We are going to cover string operations, and we're going to start covering what functions are in MUMPS. So let's get started. So I looked, and at the homework, and I found several I found several people who did some interesting stuff. So let's look at them. So I'm gonna teach you a few things in VPE. So one thing that I'm gonna start is something called RD. RD means routine directory, and you can type the name of the routine, which is I know that all your guys' routines start with the letter Z, so I'm going to type Z0 and star, and I'm going to get these three routines. And I also have an outlier. Ted wrote his routines in Ted's RLT in an outside namespace. All right. Jignesh says, GTM command not found. Jignesh, you are going to be joining my screen session. So you need to type screen -x sam/. Okay. Oh, now I see you. All right, fantastic. So, so we're gonna start taking a look at routines, and we're gonna start by Z02. Z02 RTN3. All right. So this is Tony. Let's clap it for Tony. So this is an example of a very well commented routine. And Tony, I need to wrap you around my finger and put you in my pocket. Thank you. So let's take a look at some of the interesting stuff he did. He used the new command, even though we did not discuss the new command yet. We could see here he had spy. He's entering the radius, and it looks like if the user types Q or up caret, they go to the end. He's asking here, how do we remove lines? And the answer to remove lines in VPE, it's escape D. That's the answer. I can't do it here because I'm in the reader, but this is how you do it. You type escape D and it will remove the lines. And he has an entry implemented via goto, which is okay. That's good. I mean, he has a loop implemented via goto. Then he has a tag called end, and it has he's killing the variable that he used. Now, Anthony, I would salute you for killing the variable used, but if you knew variables, you do not need to kill them. And this is not okay. All right. Okay, good question, Anthony. Why, when you knew variables, you don't need to kill them? It's not for today's class, so I'll answer you very briefly, and I'm not going to explain very in detail because this is not a subject for class. Maybe it's 8 classes. It's like 8 classes or maybe 6 classes hence that we're going to talk about the stack structure. But essentially, new creates your variable at a specific level in the stack, and once you exit out of that level of the stack, they disappear. And therefore, you do not need to kill them when you exit, because they'll disappear by themselves. All right. So this is a very good routine. So let's go ahead and run it. Ah, looks like it crashed. Now I have to figure out why. Oh, I mistyped it. Huh? Alice is asking if we did our routines in Paideia, is there any way to port them into vForum? The answer, Alice, is yes, but it's harder for me to explain than it is right now. Ted is asking, am I supposed to see what you're doing? Not in the big blue button, but you're supposed to be seeing it in the screen if you're on Putty, where you type screen minus XSAM. Okay, sorry, Anthony, I forgot your routine name already. Here we go, it's routine 3. That's why it didn't work. Here you go. It cleared the screen. Good job. Wow, I like that. -1. Oh, look at that. So, you guys saw Tony just write "uh-oh" on the chat. Well, there's a good lesson for everybody in here, and that is, whenever you write a program, whenever somebody else tries it, you're gonna find the bug right away. That's almost axiomatic in programming. Don't ever think that programming is a breeze and you write a program and it's gonna work. No, that usually never happens. So, let me see if I write the letters A, B. Oh, it lets me type the letters A, B. Okay. Oh, okay. Yeah, Linda tells me I did not do pattern matching. Okay, Linda, thank you. So, let me see if I hit enter. Okay, if I hit enter, it just accepts what I said and says the circumference is 0. All right, let's type Q to quit. All right, that's good. That works. Tony, I don't have the other routine because I only copied a few routines from the other environment. I like this routine so much I had to show it, All right, so next routine I want to look at is .rd to Z04ASN2. And by the way, when I type VRR down in VPE, that's the routine reader. So, or the V stands for victory. Don't ask me why it does. For the victory program. All right, so all right, this is our second example that we're gonna look at. So, picking up, sorry. Let's see. Okay, so what we see here is again good conventions being followed, and there's we start with the routine label, and then we see the initials of the organization that the programmer is affiliated with, then slash their initials, then an explanation of what this program does. Here it just says assignment to, and then the date. So nothing fancy here. This routine actually is remarkable in the fact that it's actually it's really very simple to and easy to follow. But there's one thing missing. Who wants to tell me what's missing at the end of that routine? There's something missing at the very end. Yep, exactly. That's missing the quit. So in order the there is nothing wrong with writing routine and not putting a quit at the end, because MUMPS hits the end of the routine, it will quit automatically. What happens usually though is people keep adding to their routines and they forget to put the quit on their old stuff, and eventually you start falling through and you continue with your routine. So let's make that fix actually. So .r to edit the routine. No, sorry. I'm forgetting. Isn't that bad? Type quit. We're gonna hit save. And now we're gonna actually run it. Okay, good. Let's try 0. Okay, it accepts 0. -1, 0. That's good. Okay. If I entered an alphabetical radius, I'll get 0 as well. I'm going to show you how to deal with that in a moment, by the way. So let's not worry about that. Okay. So let's see, then we have, I think I have now I'm going to take a look at the next example. And that would be, okay. All right. This is another routine, and you're going to notice different approaches as usual. So again, somebody news the variables and kills them at the end. You know, guys, I'm not extra credit, right? I already have one teacher pet, let's just put it that way. So, again, interesting. Again, I see that several people have different approaches to how to handle the negative number, and it's basically if r is less than 0, set r equal to 0, or some people set it at the actual set the actual circumference to be equal to 0 at the end. Wow, C is in inches. I did not know. Here we go. Right, I want you guys to take a look at this. This is interesting. So there's the loop here in order to make sure that the user continues, but it only there is a sort of a tiny problem with this loop, and that is basically it keeps looping upon itself. But to an extent, it will work. Again, extra credit. We're not going to talk about this today. Z08 routine 2, so do up caret Z08 routine 2. Enter radius, let's do 5. All right. No. Good. Oh, I see why. The radius is in inches. Now I understand. Okay, that's good. That's good. All right. And let's take a look at the last example, and that would be Ted's example. I can't remember the routine name. Okay, it's this one. Okay. My cursor doesn't want to move anymore. Is that? Yeah, I'm not sure what's going on. So, so this is Ted's homework. We can, and basically, I think it's the best homework for teaching. I'll tell you why. We basically need to figure out what Ted did wrong here. And Ted, sorry to pick on you. You're gonna have to forgive me. I know. I just picked you at random, so forgive me. But basically, uh, I am not getting. I can't move my cursor anymore. Oh, okay. Here we go. Screen minus X. Oh, it's something that has to do with VPE. That's interesting. Huh? You know, I can't, which is driving me nuts, huh? Jignesh is asking, what is pi? And a good point, Jignesh, because this program is going to crash because pi is not defined. But I don't know this. I think VPE does not like the lowercase stuff, so it's going in an infinite loop somehow. And Control C isn't working. See, Control Z perhaps will work. I'm sorry, Ted. I'm trying to get us out of the keyboard thing. I don't know what happened. Oh, sorry, Ted. What I said was, I understand now not what you're talking about. I said I'm sorry to pick about you. I'm sorry to pick on you, excuse me, for your routine. But now I have to figure out how to get out of it. Okay, guys, I think I know what to do, I suppose. Uh, all right. Oh, all right. You are Ted and Mao are being kicked out constantly. We're gonna have to figure out. Uh, I thought we're gonna have to figure out what's wrong, but I'm stuck in the editor and I'm still can't get it out. So let me try again. I thought I fixed it. Oh, it's still running. Okay, kill -9, 5487, and that should really kill it. Okay. Uh, well, according to my thing, I'm supposed to have gotten out of this, so I'm not sure why it's not working now. Okay, guys, what I'm going to do is I'm going to shut down the screen session. So let me see, control. When you wrote this originally, it would work. Which one works? Which routine works, Ted? Can you tell me? Ah. Okay. Ted, good questions. I'm gonna explain it to you, but as soon as I figure this one out, because it's driving me nuts. Any ideas, Linda? No? Okay. I think, well, we'll close out the terminal. Oh, here we go. We're out. Thanks God. Oh my God. Here we go. We're out. Thanks God. Here we are. All right. We're gonna do your routine again. We're gonna do it on the GTM prompt. And okay. So Ted, um, let me let me explain this. So Ted says he wants to learn about variable scope, and he's very confused. Oh, thank you, Ted. He's very confused about why this routine does not come out. Why does this routine keep getting the variables from the previous time ran the routine? This is a very this is a very good time. This is a very good time to discuss how MUMPS deals with variables, and we've talked about it a little bit so far, but not. But we're going to talk about it a lot more. So MUMPS has something called the symbol table. This is important. So. And no, no, Ted, that's not why it's crashing. It's crashing because you wrote the routine in work case. That's why it's crashing, which is perfectly legal, but the VPE does not like lowercase. Okay, so we're going to talk about the symbol table. So when you when you do something in GTM and basically if you set x equal to 1, that by default goes into the symbol table and is available for. Okay, sorry, Douglas tells me I'm breaking up. Essentially, that whenever you set a variable in the symbol table, like I just did, I'm still breaking up. Okay, I'm good now. All right. Whenever you set a variable in the symbol table, it stays there for future processes to use. And to see the contents of the symbol table, you just enter the word right by itself, and you get to see what's inside the symbol table. So if I set y equal to 2, and I type right again, I see the entire contents of the symbol table. All right. So let's run Ted's program and see what's it gonna tell us. So Ted's program is legal mumps, but it's not. It doesn't have. We would certainly like to give it more structure in a future version. So let's run Ted's program. So do Ted's RLT0, and here's the radius. Let's make it 4. And you're going to notice it's going to say undefined local variable pi. So what happened with Ted and why he did not encounter this problem when he was actually creating the routine is because pi was defined from a previous routine. We can emulate that by typing set pi equal 3.14141. And then if we do this routine again, actually let's do the symbol table, z right. And here you go. And let's do this. Let's put the radius of 4. And here you are. Let's see if Ted handles negative numbers. It does. Okay, Jignesh is asking, what does the do command do? The do command executes a routine. So, Ted's routine name was Ted's RLT, and we ran that, and using the do command. So, all right, thank you, Manohar. That's right. For Jignesh's sake, if you remember, and I don't remember, here's another do, and I'm gonna execute a program called %rd, and that tells me what routines are present in the system. It's the same as rd that VPE executes. And I see that there's a routine that starts with Z08 RTN2. So in order to execute it, I type do up caret, then routine name, and I get to run the routine. Does that explain it, Jignesh? Okay, good. And by the way, if anybody's interested, the main entry point to enter VISTA is up caret ZU. And just FYI. Jignesh asks, do we need to compile first? The answer is no. MUMPS is like Python and Ruby, which or even JavaScript, which most of these languages have a way of compiling their code automatically or just interpreting their code directly. GTM and Cache and many other MUMPS implementations don't do interpreted code. They actually compile it behind the scenes, just like Python and Ruby. nowadays JavaScript. So you don't worry about compilation at all. Okay. He says he remembers creating object routines. Douglas says I'm breaking up. 1, 2. Is this good? All right. So Jignesh, you have to create object files for all of the Vista routines. And Jignesh, this is something that's specific to GTM. It has nothing to do with MUMPS, and this is something we just recommend because so that the users don't get compilation error while running the application. Okay. So let's take a look. Let's go back to Ted's routine and take a look at it again. So we actually basically need to do a makeover to Ted's routine, and I'm gonna give it a makeover, just like those TV shows. So because VPE does cannot deal with lowercase stuff, so I'm just gonna use the regular system editor to edit this routine. And by the way, you don't have to do this, or shall we say, you don't have to. What's that expression? Do as I do as I say. Yes, here you go. Right. So I just opened the routine in an editor. So we give Ted's routine a makeover so that it complies with all the applicable rules in MUMPS. So let's start off with Linda. What's Ted's namespace? He doesn't have one. Oh, we did not give Ted a namespace. That's why. Okay. Sorry, Ted. That's okay. We're going to fix this in a moment, but we're going to start off by, we're going to make him Z10. All right. So we're going to call this Z10 RLT0, all capital. And then we're going to put a space, then a semicolon, or a tab and a semicolon. We're going to say that this is, Ted works for himself, so he could type Ted. I don't know your initials, Ted. I'm going to call you, I'm going to make your organization Ted and your initials TS. How about that? And then I'm going to put a dash. Then I'm going to put the purpose of the program. Then I'm going to put the date. And today's date is September 10th. Okay, so that's the first part. So Vista rules allow us to use Vista rules formally allow us to use lowercase for commands and local variable names, so we can do that. So what you do, this line is fine. And here this line says if red is less than 0, set red equal to 0, and that's okay. Now, you need to, we know from the time we executed the program that pi is not set up correctly when we run the program, so we're going to do this. We're going to say set pi equal to 3.14, and I don't remember the rest. 59, here you go. Linda remembers everything. And then, then we calculate the circumference and then we write it out, which is good. Now, as before with either I can't remember, with one of our previous routines, we are missing the quit. So we're going to put a quit down here. All right? We're going to write it, but still have a tiny problem. That tiny problem is uh, our routine is still not called Z10. Okay. Douglas tells me I'm breaking. I'll be waiting a moment. 1, 2, 3. We're good. All right. All right, Ted. Sorry, sorry about that. All right. So let's talking about Z. Talking about your routine, we still have the problem that the fact that the routine name has not changed, and even though the main label in the routine is changed, we cannot invoke it using this name. So let's try that. If I do up caret this, it does not work. So the only solution is to actually move your routine over to another routine name. And I don't think VPE has a solution for that. Does it allow you? It has a save as. Okay, Linda tells me VPE has a save as. She is absolutely right, but I'm not going to try to do that with routine. So Linda's right that says that you can rename something in VPE. So what I'm going to do is, again, another trick that you don't have to. I want you to just close your eyes and pretend that I'm just renaming the routines. How about that? Because I don't want you to learn this trick until later. All right, now you could open your eyes. I just renamed the routine. So now we could actually run it. Go. -1. Okay, it's working. That's it. Ted's routine has just gotten a makeover. And let's look at its final shape. Z10 RLT 0. Okay. So Ted, the important thing is if you're programming for VISTA, the routine names still have to be uppercase. And so are the labels, but Vista, just as of maybe 2 years ago or 1 year ago, they just recently allowed that the fact you could use lowercase local variables and lowercase commands. Oh, I'm sorry. Oh, I know. Now I figured out what Ted is having a problem with. He is having a problem with blue button. It keeps crashing on him. That is why. Now I understand. Yeah? Okay. All right. Okay. So, let me see if Ted is back. He's just back. So, okay. Ted, what I said was basically the routine names still have to be in uppercase in Vista. But if you're doing local variables, you can have them in lowercase. Or if you're doing commands, you also have them in lowercase. Now, this rule has not been promulgated through the Vista X index checker yet, so you might not be able to write VA code with these rules, but as far as I'm concerned, you're A-okay writing lowercase. So just keep that in mind. All right. So I wanted to do the rest. Oh, Douglas, I'm breaking up. I'll slow down. My goodness. No? Okay. All right. Now I'm good. That's good to know. So what I'm going to be covering today are a few expressions that oh, I'm breaking up now. No, what now? Oh, okay, I'm good now. All right. So sorry guys. I think we might be exploring something other than the blue button to do this conferencing with it breaking up so many times. So so what I wanted to discuss today was a few. We're gonna discuss Boolean expressions in MUMPS, and we have two kinds of Boolean expressions, and then the rest of our this class and the next class we will be discussing strings and string operators in the MUMPS language. And by the way, there won't be any homework for this class. So if you did not have a chance to finish the last week's homework, I would encourage you to do so. All right. So let's start with Boolean expressions. So we're going to start off with two there are basically, I'm trying to think of it. There are three what's called Unary Boolean expressions. I don't know how to spell that word. I spelled it as urinary. And then I have an extra R, Unary. How do I spell it like that? We'll figure it out somehow. And then we also have two binary expressions. We're going to start off with the Unary expressions. So, all right. Unary. Thank you. Unary expressions. Here you go. So the first one, oddly enough, is the plus sign. The second one is the minus sign. So let's see how they work. So we've done the following last class. So write 3 plus 4, and we figured out that that was going to give you 7. But if you write A plus B, that does not concatenate. That just adds 0 plus 0 because the numeric of A is 0 and the numeric of B is 0. So this is plus used as a binary. So, but in order for, we need, what we want to just see it as an Unary expression, and this is basically a different MUMPS feature than the plus sign that adds numbers up. This is right plus 3. Now, plus 3 is gonna give me just 3. That's easy. But look at this. I can write I can do plus of a string of 30 main road. Oh, that's a bad example. Let's start with this. Let's start plus of A, and that will give you 0. If we do plus of a string that starts with a number, uh, that gives us the MUMPS tries to breaking up better now. All right, that's good. So if I plus a string that contains a let me think, it contains a number, I will get the number itself. You might be wondering, who in the world would use that feature? Well, guess what? People use that feature because, let me, I'm trying to think of a place in Vista that they use it, but you often get data stored in Vista like this. So set x equal to 30 up caret, 20 up caret, Ted up caret, Alice. There you go. And so you get data stored in Vista like this. And there is a proper way to do this, but a lot of people take the shortcut way. And to get the 30, you just type plus s. And because the delimiter is not a number, it just gets the 30. So from what I've just told you, plus's main use is to convert a string to a number. We actually don't really use it in boolean because it's, it doesn't really make a lot of sense to use it. Is the minus used? How about the minus? Let's talk about the minus. We're gonna do the same example and write minus x. Now I honestly don't know what this is gonna do. Oh look, it did minus 30. I don't know what it's gonna do because I've never used it in my life, but it stands to reason that if you negate a string, you're gonna get the negative number. So, and obviously we know that, if we write minus 3, that's just a negative number. Okay, so that's the two Unary operators. There's one more, and that one we actually use all the time. The last one is, I need to spell Unary again. What's it called? Unary. Last Unary operator is just this, the apostrophe. Not tick more. Okay, which means that on a US keyboard, that's the key just right next to the enter button, not the key under the escape. So this is the same as not. So if we set x equal to 3 and we write x is equal to 3. Actually, let's make this example simpler. Sorry, guys, forget about that. Let's set x equal to 1. Then we are going to say write not x. So who wants to guess what not x is going to be? Okay. I have several being saying 0 and not x is 0. That's good. All right. So, another now we could try to set x equal to 3. Okay. Better now? Nope. Okay. Okay. Good now. All right. Let's see what minus what not x is going to be. You guys, Douglas tells me I'm breaking up again. Can you hear me? Okay, it looks like it's good now. Sort of. Douglas, it's stuff. Okay. Size, it's bad. Okay. Okay. What now? Okay, good, good. All right. So, um, I hope you guys hear me now. Does anybody want to take a guess on what not 3 is? Okay, I say is 0. Yep. Well, actually, it's correct. Now, okay, here's the more surprising question. What's not 3? Alice, 3 guess. But remember, Alice, that MUMPS executes the commands in strictly left to right order. So it's gonna essentially it's gonna get it into a 0 first, and then the not 0 is going to be a 1. So it's gonna be a 1. Okay. So, remember, guys, when we were doing the circumference program, I was entering alphabetical stuff, and it was giving me 0 as we expected. But we want a way in order to prevent users from entering alphabetical stuff in entering alphabetical stuff into programs. So how can we do that? We want them to enter a number. It's actually pretty easy. You won't believe how easy it is. Using the instruction I gave you, you could just do this. Read x, and then if plus x is not equal to x, write this is not a number. All right, let's try it. I do need to add a little line feed after the read. Okay, here we go. So if I say 8, it works okay. But if I say ABC, it's gonna tell me this is not a number. Now, guys, I'm gonna talk slow and emphasize this. All right, so ready? What makes MUMPS hard for beginners is a lot of those idiomatic expressions. That's the way I would describe this. Somebody reading MUMPS code for the first time is going to encounter a lot of these very difficult, nonsensical expressions like plus x not equal to x. you know, if you look at the language for the very first time and you're wondering what the hell is that, you're right. So this is very much like Ruby or Perl, because both those two other languages are very idiomatic. They actually have a lot of little tiny tricks to them. And MUMPS doesn't have as many idioms as Perl, but it's a few and you have to learn them. And this is one of them. Basically, when you suck, oh, sorry, Douglas. I'm breaking up. Better? Okay. So, if I am plussing something and then comparing it against itself, I am checking to see if something is a number. That's what I'm doing. Okay, so we just covered the two, the actual, the three ternary operators. Now there are two boolean operators in the fact that they actually operate on two messages. Jignesh is asking, this is not, I see that you have an 8 at the end. Is that intentional or is that a typo? Jignesh. Oh, okay. It's a typo. Okay, so that's okay, it came after it. I don't think it will become 8. Can you try it again and check? I'm gonna copy and paste it from you. How about that? Without the 8. Oh yeah, this, I don't like Flash. It doesn't copy. Okay, let's see. Oh, okay, I understand. Okay. Sorry. Oh, he says he got it. Okay, never mind. Douglas was trying to explain it to you, but you got it. Okay, good. All right. So, I gave you the three ternary operators. Now I'm gonna give you the binary operators. So the binary operators are only two. All right. So I'm gonna type binary operators. So there's an and this is an or. All right. Okay. What's important for you guys to realize coming from other languages, that it's not two and signs and it's not two exclamation marks. It's only a single one. And that makes a big difference in MUMPS because two ends will not compile. It's not valid MUMPS. So let's do the simplest example ever. All right. So simplest example ever is write 1 and 1. It's 1. All right. That's easy. Now, as we know, write 1 and 0. That's 0. Write 0 and 1. You get 0, and write 0 and 0. All right, and the OR is simple. Write 1 or 1. That's 1. Write 1 or 0. It's going to be 1. Write 0 or 1. It's going to give you 1. And write 0 or 0 is going to give you 0. So that's pretty straightforward. So question is, can we use this in real life in something useful? Yes, we can. Actually, if you've used VISTA a lot, you know that the reminder system allows non-programmers to string stuff together using these expressions. So you could put an and or an or in the reminder system, just like this. So let me give you this example. Let's come up with a real example. So, all right, that's something I'm breaking up again. All right, I'm good. All right, so I'm going to give you an example of how this would work. So, let's say set gender equal male, age equal 28. That's good enough. So what people typically do is kind of this, is they say if gender equal female and age less than 30, right? True. Okay. So, oh, okay. If gender equal female, and I'm trying to figure out what happened here. Ah, okay, I know. Okay. Oh, this was intentional. Who wants to tell me what happened? Alice, you have the spotlight on you, actually. You're the one who asked this last time. And nope, that's it. That's right. Alice, the fact, it's left to right. So you have to think like mumps in this case, okay? This is I told you guys last time we did the class, this is very annoying feature of mumps. It's one of the very worst thing in the language that it does this. So, here we go, I'm breaking up again. Good? All right. So, Manohar said that I should have used two equal signs. Manohar, there are no two equal signs in mumps. It's only in C-like languages. So let's pretend we're mumps. So what does mumps do? Mumps evaluates this expression first. All right, and it becomes 0. So mum says, okay, good. I start with 0. So let's do 0. Noted. My expression is right gender equal female. And we said in our last class that the equal is not part of a set statement, then it's doing a comparison. The only time where equal is actually doing a set is in when you have a set, like up there when we set gender equal to male. So when I say right gender equal female, it's actually comparing the two strings. So if I write gender, it's actually still male. But when I ask it right gender equal female, I'm really asking it, is gender equal to female? And the answer to that is no, it tells me no. So that it starts off with this. So it says, okay, gender equal female is 0. Now, then it runs the next statement in line, 0 and age. Now, what is age? It's 28. So that's the same as 0 and 28. 0 and 28 is 0, right? because if we're doing Boolean logic, 0 and 28 is false and true is always going to be false. Okay, so Linda asked, why did it return true? Because this is not the end of the statement. The last part of the statement was write 0 and is 0 less than 30? Douglas telling me I'm breaking up. Okay, so the last part of the program is 0 less than 30. So is 0 less than 30? The answer is you betcha. And therefore, in the end, it's going to the whole statement is going to be true. So you are going again. This is important. If you have a notebook, you should put 6 red stars on this. In MUMPS, you're always going to see a pattern, and I'm gonna make it easy for you so that you would understand how it works. In general, when you are doing conditions, multiple conditions using and or, you should put them in between parentheses. So we can write this gender equal female like this, and age less than 30. Right. True. Okay. Now it evaluates correctly. But if you read VISTA code, you will notice that programmers don't actually do that regularly. And why is that? Well, I'll show you. When you do strict left to right evaluation, the very first argument then tends to get evaluated properly. So this is also valid. So let's change this expression and make sure it's going to work properly now. All right, that does work. Now, I just want to, some of you are familiar with FileMan and input transforms. I'm just going to show you something in the input transform of any file. So let me get, I want a file that's easy enough, that doesn't have anything special on the input transform. Okay. Well, I did not choose the easiest input transform. Let's just put it that way. So. Huh? Okay. So, I just gave you a very long thing in file that FileMan executes internal as part of something that's called the input transform. You know what, guys? I don't want you to worry about most of it. You could ignore most of it. I want you to focus just on this part. Okay. This is the only part I want you to focus on. It does not make any sense, most of it, but Well, the part that makes the sense is look at that for or sign. You see that or and another or. So two or signs that express. And what I want you to notice, the first part of the expression does not have parentheses around it, and the rest of it does. So this one does not, this one does, and this one does. Okay, Douglas, looking up again. Okay. So in the end, the important lesson from all of this that you need to take back home is that you have to be really careful in doing ands or ors in mumps or putting multiple conditions together, because the best way to do them is you have to use parentheses everywhere to make sure that your code will run as designed. All right. So let's just do a simple example, another simple example to just reinforce what I just said. So let's set x equal to 5, and I'm gonna say write. Actually, if x is greater than 3 or x less than 1, write true. All right, this is good. And this will act exactly the same as the previous expression. So, I don't know if anybody wants to ask, but is there a between operator in mumps? And the answer is no, there is no between operator. So this is, in order to see if a number is greater than or less than something, you actually have to write it like this. So let's say that we want our number to be between 1 and 10. So you're going to have to say, so if you want to say between 1 and 10, right, oh, sorry. If x is greater than 1 and x is less than 10, write between 1 and 10. All right. All right. Alice asked a good question. What if you want to say equal to or greater than or equal? Alice, we covered this a little bit last class, so this is a refresher. If you want to do greater than or equal, MUMPS does not have that available. So if you do this, that does not work. What you have to do is reverse the bracket and put a negative on it. So it's, if x is greater than 1, means it's the same as less than, not less than or equal. Excuse me, not less than. Woof, woof. I'm sorry. I'm confusing myself now. So if x is not less than 1, it's the same as greater than or equal to 1. And we're going to do the same thing here. So I have this, I'm going to do this, and I'm going to say not greater, I'm going to say not greater than 10. Guys, if you want to ask me if this is confusing, I'm going to tell you it confuses me to this day. Not kidding, but this is how MUMPS works right now. So this is – 1 not less than, greater, spell as greater than or equal. Not greater than, which is less than or equal. Okay, it's looks like it's 20 open. Oh, sorry. Doug tells me I'm picking up. Okay, so I want to open this up to questions, and if any one of you guys wants to write down a question or just talk mention it, let's unmute you all. If you could actually talk in. All right, so Menage is asking any good books for MUMPS. The only book that's available on Amazon right now is called M Programming by Dick Walters. Or is it Richard Walters? Or Richard Walters. Okay, and so unfortunately it's expensive, and we are currently working on our company is currently working on at least a couple of different textbooks for MUMPS programming, and they have not been released yet. So it's something that we're working on, but this is sort of a shortage. It's sort of a tiny problem with the communities that there are not a lot of books around. Okay, Tom asks if a string has a number in the middle, plus still converted to a number. The answer is no, as we're going to find out. So if I write plus one dog and 3 cats, for example, I'm still going to get 0. So the number only matters if it's at the beginning. So if I write 3 1 dog, it's going to become 3. Any more questions? All right, guys. I suppose that's a wrap for today. And we're gonna see you guys next week. And we're gonna try to figure out a way where we can improve our audio, and we're gonna have to talk about it here because we thought our audio last time was problematic because we were sharing the screen at the same time, but looks like it's a continuing problem. So we're gonna try to deal with that. All right, and don't hesitate to email the list when if you have any questions. All right. Thank you, people. Bye.